Hello and welcome everyone today to our webinar. The title of the webinar today is Application Defined Hyper-Converged Solution for the Virtual Data Center. My name is David Davis and I'll be the moderator for today's event. Thanks so much for taking time out of your day to join us. We have a lot of really cool stuff here to talk about in the event. And for one lucky attendee, we do have a $300 Amazon gift card as well. So your day may be well rewarded. If not in Amazon gift cards, it will be well rewarded in a lot of interesting knowledge here around hyperconvergence and the possibility or what can be done related to hyperconvergence and applications. So if you have questions during the event, please use the GoToWebinar question box. We will be answering questions throughout the event. We'll also have a Q&A session at the end of the webinar. All right, so before we go too far into the event, I want to just briefly give you a little bit of background about myself and my co-presenter today, Mike Harner. Again, my name is David Davis. I'm a co-founder at Actual Tech Media, a VMware vExpert, author, blogger, a speaker, and formerly an IT manager, a system admin, and a very passionate virtualization evangelist, really, because I spent a lot of time implementing VMware vSphere back in 2007, 2008 timeframe, and that was really where I fell in love with what the power of virtualization. And so I've been writing about it and speaking about it and creating video training around it ever since. My blog is virtualizationsoftware.com, and you can always find me on Twitter as David M. Davis if you want to follow me or have questions about virtualization or hyperconvergence after the event. I'm proud to be joined today by Mike Harner. He's a senior systems engineer at Maxta. Mike has been in the IT industry now over 20 years. He's a IT veteran, and he's been an IT manager and solutions architect for a number of different vendors. He has a lot of background in the data center across all the different silos, virtualization, network, and storage. He's got Cisco certifications, EMC certifications, VMware, and of course, he's very knowledgeable about today's topic, which is hyperconvergence, software-defined, and application-defined. So thanks, Mike, for joining us today and coming on to be our special guest. I also want to thank Maxta, who is the sponsor of today's event. Now, before we jump into it, we have a couple quick poll questions here for the audience. I appreciate you taking time to answer a couple polls to help us learn a little bit about you and your company, and that helps us to tailor this event and future events as well. So if you don't mind, tell us roughly what's the size of your company out there, number of employees. And it's very interesting to see, as we've done more and more of these webinars, who is it who's interested in hyperconvergence? Is it small companies? Is it large companies? As far as I can tell from doing polls just like this one, and I'll share the results with you, it appears to be, companies of all sizes. So it looks like everyone's answered the poll there. I appreciate that. Let me go ahead and share those results. And as you can see, it is kind of across the board, but especially, 1,500 plus employees. But there's also a lot of interest all the way down there in 1 to 100. So thanks for answering that. One more quick question, and I know it's an easy one, and that is, what hypervisor are you using today? vSphere, Hyper-V, KVM, or another hypervisor? And I think it's going to be an easy bet what the winner of this poll is going to be, but I have been surprised in the past. So let me go ahead and share those results. And as you can see, 68% VMware vSphere. I think that comes right along with what the industry analysis and surveys have shown in the past, and typically what I've seen from talking to companies out there, at user groups and at events. So with that, let's go ahead and jump into the presentation. Having been an IT manager and virtualization admin and network admin, over time, I know that IT organizations of all sizes, like we have on the webinar today, are facing a lot of challenges out there. They've got challenges. They feel, like you're running on the treadmill there and you're not getting anything done most days, unfortunately. One of the challenges is just keeping up to date on new technology. I mean, whether it's learning about, software-defined storage, software-defined networking, OpenStack, vSphere, um, all sorts of, technologies, hyperconvergence. It's a real challenge to do that, and I struggle with that myself. I know that all IT professionals do. I mean, other challenges are, keeping the hardware and software up to date. Whether it's refreshing infrastructure, when lease replacement comes up, or upgrading to the latest version of the vSphere hypervisor, or keeping the SAN, software up to date, whatever it might be. That's a major challenge for companies out there. Making end users happy, of course. That's really one of our number one jobs is, facilitating technology at the business. And we can't always make the end users happy, but we do our best. And we sure could have a lot more time to do it if, keeping the technology and the software and hardware up to date, wasn't so demanding and wasn't so inefficient, right? We also have the challenge of remembering that, we're really there for the applications to not only make the end users happy, but make sure that the applications at the company run efficiently, that they perform, that they're up, that they're reliable, that the company's data is protected, and understanding the applications. I think we in IT need to do a better job of that as well, knowing what applications are out there, what their priorities are, and how we can make those applications perform well and implement new applications faster or new upgrades faster. Some companies have test and development organizations as well, and so they need to respond to those as quickly as possible. And don't forget, that old saying, we need to do more with less. I know a lot of companies are stretched thin with their IT budgets. They're forced to continue to cut the budget or keep the budget the same while supporting more and more, end users out there. And at some point, I asked myself, wasn't technology supposed to make our life easier, right? When is that going to start? I wish it would start today. Thankfully, I feel like there's more and more technology solutions out there to help us. I always keep my eye on the promise of new technology and how it can make our lives as IT admins and IT managers, more efficient, and how it can actually help us to do more with less. I mean, think of the iPhone now or whatever smartphone you have, where you can do so many things with it that used to in the past were separate devices or separate applications. So one of the promising solutions I see out there is, more efficient technology just across the board. Servers are more and more powerful today. You can do amazing things with servers, and they still have tremendous, capacity to run more virtual machines or virtual appliances or software-defined services. Software-defined whatever, networking, storage, whatever it might be. Networking and storage are really at the top of my mind. But being able to do things in the software and with the virtualization layer that used to require very expensive dedicated hardware. And that brings me to hyperconvergence, which if you're not that familiar with, we'll be talking about it just briefly in a moment. But basically using software-defined storage and distributing the storage infrastructure across commodity hardware and folding that storage into the virtualization layer, into the compute layer. That's what hyperconvergence can bring, and it can make your life more efficient as well. And then software or application defined whatever. And that's what we're going to be learning a lot about today in the webinar. So these are some of the solutions I see, the technology, innovations that I see as very promising, with hyperconvergence being, one of the most popular, hot topics out there. So utilizing software-defined storage with hyperconvergence, you essentially take, in this diagram, 3 physical hosts. You have a traditional hypervisor running across them, could be VMware vSphere, and you have this distributed storage layer that could be powered by virtual storage appliances that are intelligent enough, they're linked together, they're highly available, and the storage is distributed across the compute such that you don't need a dedicated storage area network, you don't need a NAS. You can essentially eliminate that most expensive, most complex piece of the data center in many cases, and utilize this software-defined storage that they call hyperconvergence. But there's more to hyperconvergence than just, we put the storage in the compute. It's not like we put the peanut butter in the chocolate. There's a lot more to it than that, right? And those other things are, efficiency, management efficiency, because you're able to manage the storage and the compute in one single interface. You're also able to leverage a lot of advanced software-defined storage services. So think of things that, in the past, maybe your SAN didn't have the ability to do, or you had to buy a license for it, or it was coming in the next version, let's hope, right? With this software-defined storage layer, it can just simply be upgraded and new features can be added, deduplication, compression, high availability, snapshotting, all these different things. There's a lot that you can do in this distributed storage layer, powered by software-defined storage. But what about the benefits, to the business of hyperconvergence? I mean, it can make the infrastructure deployment process much simpler because you don't have this expensive, costly dedicated storage area network. It can simplify IT operations because we talked about how you have fewer interfaces to manage and you have more integrated performance and capacity management, because these two layers, the compute layer, the virtualization layer, and the storage layer, can better work together. So we talked about no more complex storage environment to manage. At a lot of companies, they have dedicated SAN admins or SAN management teams just to keep the storage infrastructure up and running. And it's not like we're going to get rid of those people. We need educated storage people at the company still, even with hyperconvergence, but their jobs can become much easier and they can help to do better things for the company than just provisioning LUNs. Hyperconvergence can provide granular Lego-like scalability, where when you need to add more storage to that infrastructure that we looked at, you simply add another server to the compute layer, and with compute comes storage, or with storage comes compute, either one. A lot of hyperconvergence solutions also give you the ability to either scale up or scale out. So, look for that flexibility as well. So you scale by adding more blocks, and it's really this software-defined storage layer that glues it all together. Hyperconvergence provides significant performance improvements over legacy infrastructure. In many cases, flash storage is used to accelerate the performance by providing caching to the most critical applications to accelerate their IOs. So there's no need to purchase expensive flash storage arrays. And you're able to leverage, in many cases, the commodity hardware that you already have. And when you purchase new servers in the data center, not only does your compute get refreshed, but your storage gets refreshed as well. So essentially, low-cost hardware bound together by powerful software. You're also able to simplify the administrative paradigm in the data center, try to break down those silos. And virtualization did some of that, in itself, but hyperconvergence has the power to, do even more of it. We talked about redistributing staff potentially and decoupling staff, from infrastructure growth. So no more need for this, one-to-one. When we buy a new SAN, we're going to have to hire more SAN admins. And as we expand the SAN, we might have to add another SAN admin. With hyperconvergence, administering the storage can become, far more simplified. There are a number of considerations. I've spent a lot of time looking at different hyperconvergence solutions. I actually wrote a book about hyperconvergence, which, by the way, is in the handout section there in GoToWebinar. If you want to download it, it's a great hyperconvergence fundamentals book in PDF. Feel free to distribute it to friends, family, Christmas gifts. No, just kidding. Hyperconvergence, considerations. Not all hyperconvergence solutions are the same. So, keep that in mind when you look at all the different hyperconvergence, hype out there. It's easy to think, well, one hyperconvergence solution is just the same as the others, but that's actually not true at all from what I've learned. So, look for hypervisor choice when you consider the hyperconvergence solutions. Are you locked into a single hypervisor, or do you have the option to to change hypervisors or use different hypervisors if you choose to do so. What about hardware choice? You have the option to stick with your existing vendor, or to choose whatever vendor you'd like to negotiate, and go with the vendor that offers the lowest cost on your next infrastructure refresh. What about flexibility? Can you scale up, scale down? Can you what sort of flexibility does that hyperconvergence vendor offer you? And especially management ease. This is something I'm very particular about. Is how much easier will this solution make the daily life of the admin? I heard one admin's story at a conference. Actually, he talked about how used to, when he came in the morning, he had all these things to do. And with hyperconvergence, he comes in the morning, and for a while, at least for a few months, he just didn't really know exactly what to do, because things were just running well, and there wasn't a bunch of email. There weren't all these problems related to the storage or the infrastructure in his inbox from the monitoring system. Things were just running well, and he didn't really know what to do. And that's the time that they can start, the company can start using those personnel to do more, for the company with technology, implement new technology, new applications. I'm sure every IT organization out there has a long list of to-dos they wish they could get to one day. And I feel like that's what, hyperconvergence has the power to bring to an organization, is help them simplify their daily administrative tasks and be able to finally get to things that they haven't been able to get to. And then advanced functionality. What else does the hyperconvergence solution provide you beyond just, well, we put the storage into the compute? What else can it do? And that's what we're going to talk about here, in fact, related to application defined. And then finally, cost savings. There should be real cost savings, once you've implemented a hyperconvergence solution. So I talked about that book you can download, Hyperconvergence Fundamentals and the Maxed Advantage. It's available in the handout section there in PDF, so I hope you'll check it out. And then the title of this webinar was around application defined. So what is application defined? How does that intersect with hyperconvergence? Well, like I said earlier, we need to be able to connect with the technology and the applications and the resources, that are most important and critical to the company. And what's that? We need to be able to fine tune our resources, in the infrastructure, and allocate our resources and allocate our utilization to, what we're doing with our technology. So we shouldn't be just in our own bubble of technology and be totally oblivious to, all the applications that are running in the infrastructure. We need to be able to carve out our infrastructure the way that the company is, envisioning their critical applications. So if we have a critical financial application that makes 80% of the income or revenue for the company, maybe that should get 80% of the resources in the data center if it needs that type of those types of resources. So software-defined storage, and hyperconvergence together can really provide this sort of application to technology mapping, if you will. So, one example here is, how do you typically allocate storage for your applications? Well, every application, and usually different pieces of the application, for example, logs versus databases, they get different LUNs on the SAN, and those SANs, those LUNs have different RAID striping and so forth. So, every time you add new applications and different pieces of the application, they have different LUNs that you tie them to, and those LUNs have different, performance characteristics. They could be heavy read, they could be heavy write. So you just keep adding more and more LUNs over time, and honestly, it's very inefficient to do. What if you could go back to just having a single pool of storage where all your storage was in one pool, and then you could carve it up, just for the different applications that are running in the infrastructure. And to me, that's kind of, the light bulb, or the big question, that should be at the top of your mind right now, is what could we do to allocate our storage, more efficiently, and tie it directly back to the applications that we run at our company in the data center. And that's where I'd like to bring on Mike to talk a little bit about how Maxta is looking at this application defined, challenge, and what sort of solutions they feel that they bring to the table to solve that challenge. Mike?
Perfect. Thank you, David. Great stuff. Let's see. Should have control. And thank you to everybody joining in today and maybe listening recorded for taking some time out of your schedule. Again, if you missed the first part of the presentation, my name is Mike Harner, and I am a systems engineer with Maxta. So David's really done a great job of kind of defining a lot of the benefits of hyperconvergence, so we won't spend too much time on that today. What I will actually spend a bit of time on is some of the ways that Maxta, kind of takes us to 11, how we take this to the next level. So, just a quick bit about us. If you haven't heard of us before, we are funded by Tier 1 VCs, including Andreessen Horowitz and Tenya Capital, so pretty well-known VCs. And also Intel Capital, who is not only an investment partner, but they're also a technology partner. So there's some different synergies that go along with that partnership. If we look at kind of the pillars of what Maxta is founded on, the flexible, the simple, the scalable, and cost-effective, I would really highlight, the first and last, the flexible and the cost-effective as places where we really kind of take this hyperconverged model to the next level. We've won a couple of awards from CRN and Gardner, and if you're wondering, hey, how can I get a hold of Maxta software? There's really two ways to do it, and we can do some things that some of the other vendors don't do today. For example, if you had some existing investment in server hardware that maybe we could either retrofit or would work out well enough for us to run our software on top, we can actually just get you our software and you're off and running. You've deployed hyperconvergence. If this is a greenfield opportunity or you're looking to buy new infrastructure, then we actually do have what we call our max deploy option, which is basically pre-certified configurations that you would buy through a distributor. We have no stake in the hardware game. We are purely a software company, so it gives you total flexibility in how you want to actually acquire this software. Let's see if I've got... there we go. So I won't spend too much time on kind of the hyperconvergence overall, because, like I said, David did a great job on explaining this. A couple things I will note on this. He mentioned not only being able to scale out, so to be able to add additional nodes of capacity, both storage and compute, but also being able to scale up. So, if in these nodes, if I needed to add, a terabyte of capacity, everything else was looking good, I can actually just come into Maxta and add a disk or two and actually scale that infrastructure up as well as out. So again, more flexibility compared to some of the other manufacturers that are producing today. There we go. So David talked a lot about the OpEx savings around simplifying that whole stack. So we're collapsing down that traditional infrastructure, getting rid of all those different layers, simplifying what you need to do from a management perspective, and still providing enterprise class virtual machine services. So really maximizing that OpEx savings. On the same note, since we're actually eliminating all those different tiers and layers and different pieces of connectivity, we're also driving a lot of CapEx savings as well. So we utilize solid state, as most of the vendors do, to give you flash-like performance while still giving you, disk-type costs for capacity. And just kind of a quick reminder, this is actually the third in a series of webinars that we've done on Maxta, so you can find the others at our YouTube channel. And then the ebook that David mentioned, which is included in the handouts, I definitely recommend taking a look at that because it's a lot of really good information. So if there's nothing else, we've put this kind of in bold letters that you take away from today's discussion. It's really about providing you the maximum amount of flexibility for your organization. So both around software agility, Dave talked about not being locked into a single hypervisor, being able to kind of look at different hypervisors as you see fit, as well as being able to choose the hardware platform that works best for your organization. And then also, not having a one-size-fit-all for your application type traffic. And we're going to drill into this a bit more here, but if nothing else, take away the maximum flexibility and maximum choice when you're thinking about, boy, who's going to give me, the best possible number of options. Hopefully Maxta kind of resonates in your head when you're looking at solutions. So just talking a little bit about, talked about multi-hypervisor. Maxta has actually been written to be able to take advantage of pretty much any hypervisor. Today we support KVM and VMware with some integration into OpenStack, but others are due to follow. And I've heard it talked about a lot in the industry, where the hypervisor now has kind of become the sheet metal of the data center. So as kind of all the hypervisors reach a parity with each other, it no longer becomes a huge decision on features and more maybe around cost or how you actually acquire and deploy them, or your skill sets. And it may turn out to be that maybe one hypervisor becomes more popular or more beneficial to your organization in the future. You can switch over to that by having a piece of software that supports multiple different hypervisors. The multi-server piece of it, most organizations that I've talked to, it almost becomes a holy war when you start talking about one server manufacturer over another. So if you've got investments in place in terms of relationships, and also a lot of folks these days are looking at doing standardization. So not only down to a particular server manufacturer, but down to a specific model. So you may have an actual a standardized model that you're using, so that you can do things like get quantities, get units of scale from a cost perspective, as well as being able to spare hardware parts. And then this ability to scale both compute and storage independently. So with Maxta, it does provide the ability to provision what's known as a compute-only node. So if you've got a cluster configured and it's sitting great on storage performance and capacity, but you need to add a little bit more compute, we can actually add in some nodes, and these could even be blade servers, which are traditionally not good candidates for hyper-converged infrastructure. We can add those into the clusters, and they would actually just take some of the storage capacity and mount it across on these blades. They wouldn't contribute any storage capacity. So starting kind of from the left here, most of us are pretty familiar with the legacy model, right? So you buy your shiny SAN, 5 years, you own that investment. Typically it's a 5-year refresh cycle, because that's a fairly expensive investment. Your vendor of choice comes knocking on your door and says, oh, by the way, this is going to go end of sale. You need to go buy another infrastructure, and also there's a lot of great new features that we're rolling out. When you buy that new SAN, you're typically not just buying hardware, but you're also buying all of the software over as well. So it's a non-transferable license model. As hyperconvergence has blossomed, most of the folks have kind of not fixed that problem. They solve a lot of other issues that David talked about, but still, every 3 years or so, you're still having to buy not only the hardware, but also the software piece of it. And with servers, it's actually compounded a little bit, because the pace of innovation from folks like Intel is so fast these days that there may be things like the new 3D XPoint technology coming up from Intel. Maybe you've made an investment, but you want to actually be able to deploy on that. So now you want to be able to upgrade your hardware, but you don't want to have to buy all the software that goes along with replacing that piece. Maxta has solved that issue, and so when you could upgrade your hardware as often as you want for a light capacity, you never buy that particular license again. You just continue to transfer it. So if you're familiar with the VMware licensing model, where you can upgrade your hardware and just move your licenses over. That's a model that most people are very familiar with from a pure software perspective. So when we look at, and David went through some of this, when we look at legacy storage, actually there was a pro for owning legacy storage. You could actually define a LUN with specific characteristics built for your application, as long as you were only using it for that application. As soon as you go to virtualization, you're potentially looking at what we traditionally call the I/O blender effect. But it really made it easy to customize your storage for a particular application. The cons, as David also went through, is it's typically very complex to deploy. You need a lot of experts to be able to run that infrastructure. It's typically very expensive because we're buying multiple tiers of infrastructure to plug together. And also, this is typically a very rigid and inflexible infrastructure. So virtualization, as we move into the virtualization world, by its nature, is very flexible. We can move workloads between different hosts. We can move between different storage, and so trying to impose a very flexible and rigid architecture on top of something like virtualization is not a good solution for today's data center. So Hyper-Converged has come out, and they have actually resolved a lot of these issues. So much simpler to deploy because we're collapsing all those layers down. Much easier to manage. Typically a single user interface that you go into to manage all your infrastructure, and much more cost effective. We're using commodity equipment. We're removing the SAN out of the picture, and we're providing some kind of distributed file system that handles all the storage capabilities. The cons are typically that flexibility we had with the legacy stuff is not there. So we usually deploy a single global namespace or pool of storage with a single characteristic assigned to it. So if I have multiple applications running on top of this single storage pool, it's not really a one-size-fits-all. You typically need to have some sort of policy around each of your different applications so that they're treated according to what works best for your organization. And so this is one of the big places where Maxta kind of comes to the table. And so we deliver all of the traditional hyperconvergence benefits that you're going to see, with the ability to actually customize policies based around the applications you're deploying. So we do deploy a single global namespace type storage pool, but you'll see in the demo that we go through here and a couple of examples coming up that we can actually create a policy around each of your different applications and give them exactly what you require them to run at their most efficient levels inside your organization. So we'll talk about a quick example. Let's see here. So one quick use case, and this is by no means extremely deep dive testing, but we ran some quick testing in our configuration lab back at headquarters, and the purpose was to kind of test this page size attribute that we can actually change on a vDisk. So the test consists of basically two runs. Through each run, we use the tool JetStress to generate this I/O. And through both of these runs, we ran a continuous 4K random I/O workload in the background just to kind of simulate that we're actually have some other traffic in the background. So the first test that we ran was with simulating an Exchange environment with a 4K page size. So the I/O we achieved with the 4K page size was about 857 I/Os per second. Specifically for this test, and this is a fairly small cluster, so not a super heavy performant based cluster. But we ran this test again with a 32K page size, which matched more closely the allocated block size of the disk underneath, and we saw around a 20% improvement, around that 1022. And if you do the math, I don't know that we looked at the actual transfer rates, but if we did more IOs at a larger block size, that translates to a greater transfer rate, significantly greater transfer rate actually. And that 20% performance gain actually, adds, if we assume roughly a 4 IOP per user, roughly 400 additional users to our Exchange environment. And this is, not changing anything hardware-wise. This is merely changing an attribute on a vDisk to get this information. So, and I like to equate this back to the old days with when we used to deploy Windows, and you had to line up the block on a boundary in order so you didn't split your IOs, and we used to see roughly 15 to 20% performance improvements as well there. So I mean, it kind of makes sense intuitively, but it's nice to see the numbers, tested out. All right, so our next use case, and this has to deal with another attribute that we can set, and I'll show this on the demo coming up here. But those of you that work in the service provider space or even have multiple tenants, you're familiar with using, something like a vCloud Director to kind of do some fencing around networking and compute, and some of the other attributes that you can run inside of vSphere. So what this node affinity piece does from a Maxter perspective is allows us to take the underlying data and fence that into some subset of nodes as well. So, if I had different affinity groups here and I didn't want particular users' data to be able to spill out onto a different tier that you've defined, then we can actually set that up, and I'll show that in the demo here in just a second. All right. So let's get to this and see if it's starting here. All right, so this is our interface. We're going to focus today on the VM creation portion of our wizard, since that's where the application policies reside. And so it should be noted that, if you wanted to do all of this work within vCenter, we do have a plugin for that as well. So you can do everything right from the vCenter interface. I know there's a common thing that I've heard over the years, hey, I want that to be my single pane of glass. Or you can come into our management interface here, which we call MX Insights. We do write to the vCenter APIs, so all of this information should look pretty familiar. Give this guy a name. You can choose data center if you have multiple data centers. You can choose your operating system of choice, and then assign the number of cores and CPUs and virtual memory as you're used to doing. We will choose a host on which to deploy this initially. You can assign an ISO file here if you have an actual ISO that you wanted to be able to deploy from. We can choose our virtual networking. And now this window is really where we start to get to some of the advantages that Maxter brings from a application optimization. So, these are things that you can actually deploy on a per virtual machine basis. So I could have 100 virtual machines running across my cluster, each with a different policy associated to it. Some of these things consist of, the number of replicas, and replicas are how we actually protect your data in a hyper-converged cluster. So that we can choose to have either 2 copies of each piece of data or 3 copies of each piece of data sent across your cluster, so that if we lose a specific component, a disk or a host, for example, we've got at least 1 additional copy that we can actually fall back on. The rebuild priority kind of deals with failure scenarios. So in the event that we lose an actual host, any VMs that were running on that host obviously will get restarted as part of the HA process in vSphere. We put all of that data inside of a queue, and the virtual machines that have the highest priority, for example 10, will get rebuilt first, and that really has to do with building that secondary copy of data and getting that virtual machine back up and fully protected. And so if you've got a SQL server, that obviously would probably be more critical than, say, a print server. Likewise, we do have a capability for doing metro clustering, and this really refers to using synchronous replication across different pieces of our architecture. So you could define when you actually install the system, if I've got a couple of different nodes in multiple racks spread across the data center, or maybe different buildings across the campus, or even different data centers inside of a metropolitan area. We are going to require 5 milliseconds or less round-trip latency time, which is pretty standard for synchronous replication. But with this infrastructure enabled, we could actually suffer the loss of some significant portion of your cluster and still guarantee that we've got a redundant copy of your data sitting at another location. Striping has to do with how we actually lay the data down across the cluster. So by default, we're going to use what's called horizontal striping. And this really, we're going to try to stripe the data as widely as we can across the cluster to take advantage of parallel writes on solid state and spinning disk. If we unmark this, that gives us what is commonly known as data locality or vertical striping, in which case we will actually place the primary copy of a virtual machine's data on that host where the VM is running, and then we'll send a secondary copy off to another host in the cluster. So again, giving you your choice in regard to what works best for your application, and really you probably have to do a little testing to see what performance metric works best for you. But again, choice is always better. Under our advanced settings window, this gets to what I was talking about in our service provider example. So this is our node affinity option, and we can set this up to be either kind of a soft or a hard model, meaning that if I do restrict the number of hosts data can go on to, if I do it in a soft manner, I'll just basically get a warning, but I'll still allow that write to happen. If we do it in a hard manner, that's essentially putting up a hard fence, and it will restrict the actual data from being written if I run into a contention. And so this screen is where we can actually select the host that we want that data to be fenced into. Again, giving you some good ability in a multi-tenant environment to be able to restrict that data down. So our final screen here deals with the vDisks, and of course most of this should look fairly standard to you, those of you that are doing VM creation inside of VMware. Most of these attributes are fairly standard. We do add a couple of significantly different ones. So the key one is this page size attribute, and this is where we did that testing in that first scenario where we changed the page size to match up with what we had allocated from a virtual disk perspective, allowing us to more cleanly write down IOs from memory down to disk. So that's a pretty big change from your standard vDisk deployment options. We do have standard things where you can select a particular RAID controller or RAID type. And then we also can turn on or off our read and compression features. So again, based on whatever you're deploying, if you're deploying, say, a log file for a SQL server, it's probably not going to read back. It's going to do sequential writes, so we could maybe free up some of that read cache and allow you to use that somewhere else. Our compression is inline, so if you know that you're trying to compress a workload that isn't compressible, maybe you turn that off because there's no sense eating CPU cycles. But again, it's based on your knowledge of what you're trying to deploy in your infrastructure, and you can always come back in and enable or disable these functions as well. So we'll add a couple of disks here, and each one of those vDisks can have its own different settings. So we'll submit this, and you'll see at the bottom, this is our Manage VM screen. At the bottom, we're waiting for this task to complete. So again, we're kind of reading from the vCenter APIs and getting some feedback on what's going on. This guy should complete here in a second, so he's all done. And now I just want to show that even if we had created this in vCenter, or we had created it previously with a different set of configuration options, we can still come in here and actually change some of this information. Likewise, we can go in and look at the actual vDisk underlying it and actually change some of the different configurations here as well. So that concludes our demo. I think I have one more slide here. So really, our value proposition is, maximizing your choice, both across software as well as hardware. Your flexibility, how you want to grow the infrastructure. Do you want to add compute? Do you want to scale storage? Do you want to, use a particular hypervisor? Being able to transfer that software license is a huge difference in this type of industry, as well as the application-defined stuff. Hopefully that was fairly intuitive, and you kind of learn a little bit more about how we do some of that stuff. Maximize your simplicity. You want to manage your virtual machines, not storage. Again, David talked about nobody really gets paid extra for creating more LUNs. So the VM becomes the actual unit of management, and then maximize your cost savings. So commodity type components and optimized for capacity using some of our data optimization technologies. I think that's my final slide. David, I think there was one more poll question coming up here.
Yeah, great job, Mike. I really appreciate the demo there about how you all can be more application-defined, application-centric in hyperconvergence. We've got a ton of great questions here from the audience, and we have our gift card drawing coming up in just a minute. But first, we've got just a few quick poll questions for the audience. The first one is, are you planning a hyperconverged deployment? And if so, what's your timeline? I appreciate everyone answering that. And once you're done, if you have any questions, please put them in the GoToWebinar question box. We'll be doing a Q&A session here in just a minute with Mike. All right, with most everyone answering that, let me go ahead and let's ask real quick about your applications. What applications are you running in your data center, in your cluster today? So, Mike, while these questions are coming up, I know one of the questions from the audience was about applications specifically, and in your use cases you showed with the first application, I think it was it SQL or Exchange, that if you modified the block size, the performance was increased. And so the question for the audience was, how do you know what size to choose?
Yeah, and that really kind of gets into looking at best practices from your application vendor, right? So typically, if you're looking at SQL Server, for example, they typically are going to recommend a 64K allocation block size underneath. So we would line up our page size with that. But something like VDI may benefit from a smaller block size, like 4K, the default. So it's really, kind of understanding from the vendor you're purchasing the software from around what they're going to recommend, and then we can line up, appropriately with that guideline.
Okay, great. Well, I think everyone's answered the poll questions. Let me go ahead and close these, and then I'd like to quickly announce our grand prize winner of the $300 Amazon gift card, and then we'll jump into our Q&A session. So based on all the attendees live today, the winner is Kenny Fung. We'll be contacting you via email. Congratulations, and thanks everyone else for attending today as well. And with that, tell us your questions. What are your questions about hyperconvergence, software-defined storage, application-defined hyperconvergence? What can we see if we can stump Mike with today? So, Mike, one of the questions out there is around flash, storage and SSD. Is that something that Maxtor requires be in the servers that are running the hyperconverged infrastructure?
Yes, so we actually do leverage solid state. So, kind of the key with hyperconvergence is giving you SSD type performance while using lower cost spinning disks for capacity. So we actually do we leverage read and write cache inside of solid state as well as our metadata tier. So the answer is yes, we do require solid state, and we do have some guidelines. So for example, write cache is typically 150 gig. Read cache is typically, we usually recommend about 300 gig, and then roughly 5% of your total host's storage capacity allocated towards our metadata infrastructure.
Okay, and that 300 gig recommendation, is that per server or across a cluster or?
That would be per server, correct.
Okay, okay. And what about hypervisor support? What hypervisors do you all support?
So today we support KVM and vSphere, of course, with some plugins for OpenStack as well. As I mentioned, we've been designed to be able to work across multiple hypervisors, so you'll see more from us in the future, but those are the ones that we currently support today.
Okay. Someone here is asking about, the deployment process. Say they have an existing vSphere infrastructure, it's connected to a SAN or a NAS, they're interested in deploying Maxta. Can you kind of walk us through what the process would be like?
Sure. So we, a couple of unique things that we can do that, from what I've seen in the industry, not a lot of other folks can do, is we can actually repurpose some of that infrastructure. So the actual installer for Maxta, it's a Windows-based installer. You run it from Windows machine, point it to vCenter, give it some IP addresses and credentials, and it will go out and actually deploy the infrastructure across the different hosts. So it's a very simple implementation process. That being said, if we were going to utilize some existing disks, there typically need to be disks that aren't partitioned, so essentially new disks. But we can do some cool things with we definitely want to pre-certify it to make sure it's going to work effectively, but we can do some things with taking existing storage volumes. For example, if you've got an investment in a particular storage array, and actually mounting that to the hosts and actually putting our software in front of it. So we would actually act as kind of a caching tier in front of the disk on the back end. So there's some kind of unique things we can do that gets more towards that flexibility piece we've talked about.
Okay. And in that cluster, can it be a mix of different servers, or what's the requirement there?
Yes, we can have different servers. They can be different generations. Standard best practices around virtualization are going to apply. You always want to keep things as similar as possible so that you don't run into contention or constraints. But if you have some servers that have more storage capacity, it's not a big deal if they're a generation or two behind some of your other stuff. This is built to be to have multiple generations of hardware in it, and then you can just upgrade the components that you see fit.
Okay. So in that deployment question from before, they're asking, what if, so you add some disk, or maybe a lot of servers just have extra local disks that aren't used if you have a SAN. So perhaps those disks could be used, you deploy Maxta on it, and then can you just do a storage vMotion of the virtual machines from the SAN to Maxta?
Yeah, you should be able to mount, because we're running on top of a standard ESXi host, for example. So once you deploy Maxta and see the data store there, you should be able to mount that volume that those LUNs are on and do a standard vMotion, storage vMotion over to our data store. And yeah, we're going to look like NFS from a storage perspective on the VMware side. And so, yeah, we should be able to use standard rules for migrating data.
Okay. And is there a specific vSphere license they're asking about? Do you need a certain edition of vSphere to use Maxta?
We do not. So if you want to run, your remote office, branch office stuff on Essentials Plus, that's totally fine with us. We do require vCenter because we do integrate into all the magic that the vCenter APIs provide. So as long as you have vCenter deployed with it, then that's perfect.
Okay. Another question out here from the audience is, what's the minimum cluster size?
Minimum cluster size, as with most of the hyper-converged solutions, is three, because we are providing a truly distributed file systems with, you know, doing quorums and elections and whatnot. So three is the minimum.
Okay. And is
Now,
there
just to add to that once real quick, as I mentioned, we can do the compute and storage. So we can do things like, at a remote office, branch office, where maybe two hosts would contribute storage and one host would just be, a smaller compute only type node. So there's some flexibility around that as well.
okay? So you can have compute only nodes, and now is it true that the nodes can be varying in size in terms of the amount of storage that they contribute to the cluster?
Yes, they can. Again, gets back to typically in a virtualized environment, you want to keep things as similar as possible, but it's not required.
Okay. Okay. Interesting. Um, what about, of course, one of the benefits I talked about, with hyperconvergence is there should be some, cost savings. How is Maxta priced, and how do what in what way does Maxta provide cost savings in your opinion?
So for a couple of different ways, one is our cost of entry is typically much lower than you're going to see from, most of the bigger, hyper-converged vendors. So there's certainly that. We talked a lot about the transferable software license. That's a huge one. You're not repurchasing that infrastructure, the hardware and software every couple of years, but also the ability to be able to leverage customers' existing investments. Maybe you bought servers 6 months ago and didn't know about Maxta, or even if it's a generation old on CPU and server manufacturer model, we can often reuse that infrastructure without having to have you buy greenfield equipment and and do things like that. So most people are very pleasantly surprised when they get their quote from Maxta, especially if they've seen other manufacturers' pricing.
Okay. Okay. And I mean, I know you can with Maxa, you can use your existing hardware vendor, and I mean, I really like that being an IT manager that you can, negotiate with the vendor who offers the lowest cost on the hardware. I think that gives companies a lot of, flexibility that they really need.
Yep.
Yeah, so let's see, we're running out of time here, but I think last question is someone's asking, okay, how do I try it out, or is there what do I do a proof of concept? Do you do a live demo over the web, or what's the best way for them to get more experience or some hands-on experience with it?
Sure. So there's a couple ways. One would be we do have some lab units, kind of cloud-based, that we can actually assign to you for a week or so. You can upload data if you want to. You can kick the tires, do whatever testing you need to do, and not have to spin up any infrastructure on your own. So that's certainly an option. The other one, doing proof of concept. We'd want to work with you just to make sure that you're going to have a good experience. We've got kind of a minimum set of requirements depending on what you're wanting to test. But once we've kind of figured that all out, we basically just give you demo license keys, and you download the software. We'll help you deploy it, and you're off and running.
Okay. Excellent, excellent. Well, I think that's all we have time for today. I really appreciate your insight and demonstration on application-defined hyperconvergence.
Thank you, David.
Thanks, Mike, and thanks everyone for joining us. Have a great day.